Hello everyone, this is a new video on quantum mechanics, numerical solving. Okay. So here we'll be solving more numericals from quantum mechanics. Okay. Mostly previous year questions were from GATE and GIST and NET. So this will be a question number 30 in this series. Consider a particle of spin s is equal to 3 by 2. The lowest energy value of the particle corresponding to the Hamiltonian h is equal to this much. Okay, is. So we are asked the lowest energy value of the particle corresponding to the Hamiltonian, that is given this one. Okay, Hamiltonian is given. So let me write Hamiltonian h is equal to epsilon naught by h cut square, epsilon naught by h cut square, sx square plus sy square, sx square plus sx square plus sy square, okay, plus epsilon naught by h cut, epsilon naught by h cut, sz, sz. Okay. So here what we have to do, we know that we know s square is equal to what? We know s square is equal to sx square, sx square, sy square plus sz square. Okay. S square is equal to sx square plus sy square plus sz square. So sx square plus sy square is equal to sx square plus sy square is equal to s square minus sz square, right? S square minus sz square, right? So let's put this value here in place of here. So epsilon naught by h cut square, epsilon naught by h cut square, s square minus sz square, s square minus sz square plus epsilon by h cut plus epsilon by h cut is z. Okay, plus epsilon by h cut is z. Okay, so you can give this cap sign here, here. S square minus sz square, the epsilon by h cut is z, right? So the expectation value will become what? The expectation value of h cut, sorry, h bar, that means your Hamiltonian expectation value of Hamiltonian will be, I will simply write epsilon naught by h cut square, epsilon naught by h cut square, s square, okay, s square minus sz square, square minus sz square, expectation value of s square minus expectation value of sz square plus epsilon naught by h cut plus epsilon naught by h cut, expectation value of sz. Okay, expectation value of sz. So now we know expectation value of s square will be how much we can write. We can write it as what? H cut square. We can write it as h cut square a whole into s plus 1. Okay, h cut square a whole into s plus 1. And if of sz square is equal to what? Expectation value of sz square. We can write it as ms square h cut square. Alright, yeah. So we'll just put it there. So if we put it, we'll get Hamiltonian, expectation value of Hamiltonian is equal to, I'll just put these values here, right? So it will become epsilon naught by h cut square, epsilon naught by h cut square, then h cut square s whole into s plus 1 h cut square s whole into s plus 1 minus ms square h cut square. Okay, minus ms square h cut square plus what? Epsilon by h cut, epsilon naught by h cut, ms h cut. Okay, ms h cut. Right. So these h cut will be cancelled out. This h cut square will be cancelled with this one. So this one will become epsilon naught a sol into s plus 1 epsilon naught a sol into s plus 1 minus ms square plus ms plus ms epsilon naught. Okay, so what can I do here? I can take the whole epsilon naught as common. Okay, so I can write it as I am simply write it here. Epsilon naught s sol into s plus 1 s into s plus 1 minus ms square plus ms, right, plus ms. Yeah, this is it. Then what can I do? Then what is the question? So for particle of spin s is equal to 3 by 2. So I have to find for s is equal to 3 by 2. So tell me for 3 by 2, just a second. Okay, so I have to do what? I have to do particle of for a particle of spin is equal to 3 by 2, isn't it? Particle of spin is equal to 3 by 2. So for s is equal to 3 by 2, what are the ms values? Ms values are 3 by 2, 1 by 2, okay, minus 1 by 2, and minus 3 by 2, isn't it? 3 by 2, 1 by 2, minus 1 by 2, and minus minus 3 by 2. These are the ms values for s is equal to 3 by 2. Alright. So let's put in place of these ones. Okay, we'll just put it. So expectation value of h is equal to, we'll just put it there. That will be what? Epsilon s whole into s plus 1. That means 3 by 2 whole into 3 by 2 plus 1. 3 by 2 whole into 3 by 2 plus 1 minus ms square. Okay, that means we have taken now. Okay, I will write it here. We have taken s is equal to 3 by 2 because we'll take 1 values. Okay, first we'll take this, then we'll take this. Okay, we'll take them separately. Now ms, yeah, s is equal to 3 by 2, ms is equal to 3 by 2. Well, calculating for that. Okay, so this one, then 3 by 2 square ms square na here, ms square, square minus or plus, sorry, plus 3 by 2. Okay, 3 by 2. So if we calculate it, it will be epsilon naught. This one is what? 3 by 2 into 5 by 2, that is 15 by 4. 15 by 4 minus 9 by 4 minus 9 by 4 plus 3 by 2 plus 3 by 2. Alright. So this is your 6 by 4. So 6 by 4 is your 3 by 2, isn't it? 6 by 4 is your 3 by 2. So 3 by 2 plus 3 by 2 will become what? 3. So this whole thing will become 3. This is your 3 by 2 plus 3 by 2, that is 3. So this is your first energy. E is equal to, we can write this one as E also. Okay, E is equal to 3 epsilon naught, right? Or E1. E1 is equal to 3 epsilon naught. Exactly like that. Now we'll do what? We'll put S is equal to 3 by 2. S is equal to 3 by 2. Pull the second value of Ms, that is 1 by 2. Ms is equal to 1 by 2. Okay. So Ms is equal to 1 by 2. So this becomes what? E is equal to what? For example, this is E2. So E2 becomes what? Epsilon naught, epsilon naught, and this one is becoming 15 by 4 again. 15 by 4, 15 by 4 minus 1 by 4, because 1 by 2 whole square. 1 by 4 plus 1 by 2, isn't it? Plus 1 by 2, right? Plus 1 by 2. So this whole thing becomes, if you see 4, 4, this one becomes 4, this is 2. 15 minus 1 plus 2, that is 12 by 4. Sorry, let me do it. So 15 minus 1, okay, plus 2, okay, plus 2 by 4, that is 16 by 4. 16 by 4 is of how much? Is of 4. So this one becomes 4 epsilon naught. 4 epsilon naught. Okay. So E2 is of 4 epsilon naught. Now E3, third energy value. Here we will take S is equal to, as usual, 3 by 2. But what is the value of Ms? Ms is equal to minus half here. Right? Ms is equal to minus half. So E3 will become what? 15 by 4, because this is 3 by 2, that is same. 15 by 4 minus 1 by 4 minus 1 by 2. Alright, this is minus, that's a minus. 15 minus 1, 14, minus 1, 13. Sorry, this becomes 4, so 12 by 4, that is 3 epsilon here. So epsilon naught is also there. 3 epsilon naught. Okay, 3 epsilon naught. So now for S is equal to 3 by 2, S is equal to 3 by 2, Ms is equal to minus 3 by 2, Ms is equal to minus 3 by 2. Alright, E is equal to how much? E is equal to, this one will become what? 15 by 4, 15 by, this one will become 15 by 4 minus 1, 9 by 4. Okay, because 3 by 2 square minus 3 by, minus 3 by 2 is equal to, this one will become what? This one becomes 0, because this is, if I take this is 4, this is 15 minus 9 minus 6. This one becomes 0. Right? So these are the energy values. If I see now, this is a 3 epsilon naught. This is a 4 epsilon naught. Another 3 epsilon naught. And another one is 0. Right? Yeah. Okay. So this was a question. Next question. The state of hydrogen atom is 2p state. Hamiltonian of order, Hamiltonian of spin orbit interaction is given by H is equal to A L dot S. Okay. So the energy eigenvalues of the state are, the state of the hydrogen atom is in 2p state. Alright, state of the hydrogen atom is in 2p state. So yeah, please try first and we'll do it. See, we know what? You can pause the video also. J square. Otherwise J is equal to L plus S, isn't it? J is equal to, we know J is L plus S. Okay. So if I take the square on both sides, this is your question number 31. So if you take the square on both sides, that will be your J square. J square is equal to L square plus S square plus 2L dot S. J square plus L square plus 2L dot S. Okay. So this becomes J square minus L square minus S square all divided by 2 is equal to L dot S, right, is equal to L dot S. So L dot S is this much, isn't it? So now we'll just put the values of J, L, S. J is equal to what? J is equal to H cut square. J is equal to H cut square. J whole into J plus 1. J is equal to H cut square. J whole into J plus 1. L whole into, sorry, this is J square. J square. L square is equal to H cut square. H cut square L whole into L plus 1. L plus 1. And your S square is equal to S square is equal to H cut square. H cut square A whole into S plus 1. Right? A whole into S plus 1. So this is a hydrogen atom is in 2p state. Alright. So P for P, L is equal to how much? L is equal to 1 because SPDF, isn't it? SPDF. So SPDF, your S for S, L is 0. For P, L is 1. For D, L is 2, like that. So for P, L is 1. And for P, L is 1, right? Yeah. And what? S is how much? Here this is 2. So 2s plus 1 is equal to 2. So 2s plus 1 is equal to 2. So this is, I think this should be written over it. Okay. So S becomes how much? S becomes half. If you calculate it, S becomes half. So S is half. So L is 1, S is half. How to get J value? J is what? J is what? L minus S to L plus S. So J is L minus S to L plus S. J is L minus S to L plus S. So L minus S is what? Half. And L plus S is what? 3 by 2. Okay. L minus S is half. L plus S is 3 by 2. Okay. So now we will do separately for J. What is the question now? The energy eigenstates. So this is the energy eigen because L dot S is this one. So your Hamiltonian is A into L dot S. Whatever we get as L dot S, we'll just put it here. So we will do it separately for J is equal to half and J is equal to 3 by 2. So we will calculate what? L dot S for, now for what? For J is equal to half, isn't it? For J is equal to, sorry, for J is equal to half. So let's do it. So L dot S is how much? L dot S is how much? L dot S is, as we have written, h cut square. L dot S is h cut square J whole into J plus 1. J whole into J plus 1 minus L whole into L plus 1 minus L whole into L plus 1 minus S whole into S plus 1 minus S whole into S plus 1. Okay. Whole divided by 2. Okay. So h cut square J on half whole into half plus 1, that is 3 by 2. Half whole into half plus 1, that is 3 by 2, minus L is how much? L is 1. So 1 into 2 minus S is your half. So half whole into 3 by 2. Half into 3 by 2 whole divided by 2. Okay, so this will be cancelled. This is minus 2 by 2, that is minus 1. So this becomes minus h cut square. Minus h cut square. So h will become what? For one value, h will become minus a h cut square, isn't it? Is it? See, h cut square, no? Minus 2 by 2 minus h cut square. So I will put the ls value here, l dot s. So minus h cut square is one answer. We will check for the other one. That is l dot s for j is equal to 3 by 2. Okay, L dot S for j is equal to 3 by 2. J is equal to 3 by 2. Alright. So L dot S h cut square j whole into j plus 1. Okay. J whole into j plus 1 minus L whole into L plus 1. L plus 1 minus S whole into S plus 1. J into j plus 1 minus L into L plus 1 minus S whole into S plus 1. Okay. So whole divided by 2. So j is 3 by 2. So let's put it. So this is h cut square. J is 3 by 2. That means 3 by 2. 3 by 2 into 5 by 2. 3 by 2 into 5 by 2 minus L is what? 1, right? L is your 1. So 1 whole into 2 minus S is your half. So half into 3 by 2. Alright? Half into 3 by 2. Okay? Whole divided by 2 is there also. Whole divided by 2. Okay? So this one is h cut square, and 3 by 2 and 5 by 2 is 15 by 4. Okay, 15 by 4 minus 2 minus 3 by 4 minus 3 by 4 whole divided by 2. Okay, so if I take the LCM in the numerator, LCM in the numerator as 4, so this becomes 15 minus 8 minus 3 whole divided by 2. So this becomes 7 minus 4 by 4, 1 by 2 is h cut square by 2. Okay, h cut square by 2. Alright, so L dot S is h cut square by 2. So h should be what? A h cut square by 2. A h cut square by 2. Alright, so a h cut square, one is minus h square, another is a h cut square by 2. So two values, we got it. Okay, this comes at 2 mark question in GATE or 5 mark question in CSNet. Right, so you should be able to do it. It's very easy, nothing is there. It's very easy. Right, it's a bit lengthy, but if you practice it more, you can do it very fast. Right, yeah. So next question number 32. Question number 32. Okay, similar type of question. See, just 2018. What is the difference between the maximum and minimum eigenvalues of a system of two electrons whose Hamiltonian is given as what? For example, Hamiltonian E. Hamiltonian is H plus, is this H? No, this is H equal to, okay. H equal to J dot S plus S1 plus S1 dot S2. So Hamiltonian H is equal to Hamiltonian H is equal to J S1 dot S2. Alright, J S1 dot S2 here. So this is the Hamiltonian here, where S1 and S2 are the corresponding spin angular momentum operators of two electrons. Okay. Spin angular operators of two electrons. Okay. So two electrons are there. Two electrons are there. Okay. Two electrons are there. So two electrons. S1 is equal to what? For one S1 is half and S2 is half. S1 is half and S2 is half, isn't it? Two electrons. S1 is half and S2 is half. Alright. So again same thing. So S, do you know S is how much? S is how much? S1 square. S square is how much? Sorry, S is how much first of all? S is S1 plus S2. S1 plus S2. So S square is how much? S square is S1 square plus S2 square plus 2 S1 dot S2 is 2 S1 dot S2. Alright. Now we need S1 dot S2. Same kind of question. So I will take everything to the left side and S1 dot S2 will become what? S1 dot S2 will become S square minus S1 square minus S2 square whole divided by 2. Okay. So now see S1 is half, S2 is half. So S values are what? S values are 0 and 1. S values are 0 and 1. Okay. So S, first let's put the value as 0. We'll first do for 0. S is equal to 0. So for S is equal to 0, S1 dot S2 will be how much? S1 dot S2. S1 dot S2 is how much? S square. That means S square means S1 to S plus 1, that is 0. Minus S1 means S1 plus S2. S1 plus S1, that is half into 3 by 2. S1 whole into S1 plus 1. Minus S2 whole into S2 plus 1. That is half into 3 by 2. Okay. Half into 3 by 2. Whole divided by 2. This one is h cut square. Okay. So this one minus 3 by 4, minus 3 by 4, minus 3 by 2. Whole divided by 2. That is minus 3 by 4. So this is a minus 3 by 4 h cut square. Alright. This is for what? S is equal to 0. Now we can calculate for S is equal to 1 also. S is equal to 1. For S is equal to 1. For S is equal to 1. S1 dot S2 will be how much? S1 dot S1 dot S2 will be how much? We'll just put the value as 1. So 1 over into 1 plus 1, that is 1 into 2 minus, same thing remains there, half into 3 by 2. Okay, half into 3 by 2 minus half into 3 by 2 minus half into 3 by 2. Okay, whole divided by 2 h cut square. Okay, so this becomes what? 2 minus 3 by 4, 3 by 4. 2 minus 3 by 2, that is 1 by 2 by 1, 2, that is 1 by 4 h cut. So this one you calculate yourself. Okay, you don't need to calculate it again. Okay, so what is the question? The question is, you see, maximum and minimum values. Okay, what is the maximum value? Difference between maximum and minimum. This is the maximum value. This is the minimum value. Difference will be how much? Difference will be simply difference del is equal to, or del s whatever, 1 by 4 h cut square minus of minus 3 by 4, isn't it? Minus of minus 3 by 4 h cut square. So that will be what? 1 by 4 plus 3 by 4, that is 1. So the answer is h cut square. Is it clear? It's very simple question. Answer is h cut square. And j is there, right? J. So we can write j h cut square. And I think they have taken h cut square as 1. Okay. In many questions they take h cut square as 1. So the answer will be only, if if you put h cut square 1, the answer is what? J. So the answer is what? J. Right? Answer is J. Option D. It will be given in the question. Don't worry that, or take h cut square as 1. Okay. Or answer in terms of h cut square. Okay. So this is a question number 32. Okay. Next is question number 33. Try this question. Prove that prove that exponential I theta delta is equal to cos theta I plus del I sin theta. Where I is the 2 by 2 unit matrix, theta is a real number, delta is one of the three Pauli matrices, and Pauli matrices are given by this. Okay, so try. You take 2 minutes to try this question. Otherwise, you can pause the video. I will solve it. Pause the video and try to solve. See, exponential. I will solve it. Exponential I theta delta is equal to what? See, this is the formula here. You have to do. Remember this one. Summation n is equal to 0 to infinity. Summation e is equal to 0 to n is equal to 0 to infinity I to the power n, I to the power n, theta delta, sorry, theta delta to the power n whole divided by n factorial, whole divided by n factorial is equal to how much? Is equal to 1 plus 1 plus I theta delta, 1 plus I theta delta minus, you can just keep putting a n here. First I put a 0, right? Then 1, okay, then 2. Because of that 2, I to the power n becomes minus, okay, and everything becomes squared. Theta square delta square by 2 factorial. That means 2 minus I to the power 3 is I minus, like minus I, theta cube delta cube divided by 3 factorial. Okay, let me write it 2 factorial, 3 factorial plus delta fourth, sorry, theta fourth delta fourth, theta fourth delta fourth divided by 4 factorial. Okay, and it will go on and on. It will go on and on. Okay, so we can do from here is we can take the, so we can do like this. We can take the real parts out on one side. Like this is 1 minus theta square delta square by 2 factorial, by 2 factorial plus theta fourth delta fourth by 4 factorial, by 4 factorial plus I whole into the cube terms, the odd terms will come here, like odd powers, theta delta minus theta cube delta cube by 3 factorial, by 3 factorial, and it will go on. Okay, like theta 5 del 5 theta 5 del 5 by 5 factorial. Okay, so this will go on and on. And what can I do? See, we know del x, sorry, sigma x, Pauli matrix sigma x into sigma x, that is sigma x square is equal to what? Sigma y square is equal to sigma z square is equal to what? I, isn't it? Isn't it I? So here in the question, if you see, they are given delta is the Pauli matrix, isn't it? So delta square, all the delta square will become what? One. Delta square del fourth will become one, but delta odds will remain as delta, isn't it? Because sigma x square into sigma x is what? Sigma x. So the delta will remain, but the square will like go away, like become one. So one minus theta square by 2 factorial, theta square by 2 factorial plus theta fourth by plus theta fourth by fourth factorial, 4 factorial, and it will go on plus I theta delta minus theta cube delta by 3 factorial, theta cube delta by 3 factorial plus theta fifth delta first plus theta 5 delta divided by 5 factorial by 5 factorial. Alright. So yeah, this one. So we know this is the expansion of cos theta. Okay, cos theta, and this is the expansion of what? Uh, if I take all the deltas out common, okay, if I take all the deltas common, so I theta minus this theta minus, so this is the expansion of sine theta. So I can write it as what? Cos theta plus I delta plus I delta sine theta. Okay, so this is the answer. Right, this is what we had to prove. Right, this one we had to prove, so we proved it. So this is a proof. Okay, so this question is very important question because of the expansion and all, and very conceptual. Okay, in the question it won't come in the exam. It won't come like prove that. It will come like which of the expression is correct. It will be plus. It will be minus. Somewhere delta will be inside. Theta will be outside, like that. Okay, so this is your question number 33. Now question number, yeah, I think this much was enough. There is no more question here. So we did some 4 questions in this class related to angular momentum, spin angular momentum, Pauli matrices. So hope you understood everything, and if you don't, please give me in the comment section. Alright, thank you very much.